Thank you for having me at the Safety Connect 2021 Safety Conference. My name is Jan Nel. I'm the Operations Manager at Depth Marine Namibia. We look after a fleet of 7 vessels recovering diamonds off the coast of Namibia. Today I'm going to talk to you about managing risks that change by the minute. Let me cover the shareholder structure of the company. We've got 2 reputable shareholders, the Government Republic of Namibia and De Beers, that owns 100% of Depth Marine Namibia. Our recovery pipeline, first is geophysical surveys. We survey and map the area. We then sample the area with a sampling vessel, and that then feeds the recovery fleet of 7 vessels. Our latest vessel, the Benguela Gem or the AMV3, will join the fleet at the end of this year, early next year. Our operations require extensive logistics and marine support. Our vessels remain at sea for an average of 3 years before returning to a port, into a dry dock to do some maintenance. We're a 24/7, 365 operation. The vessels are supported via launch and helicopter. People are transferred via helicopter and fixed wing, and then helicopter from arrangement onto the vessels at sea. And then launch operations from Lüderitz and from Port Nolloth, where all the supplies and spares are delivered from. We produce our own freshwater on board. On average, there's about 60 crew members on board the vessel. The crew rotates on a 35 days on, 35 days off crew change schedule. Crew changes via helicopter, and we work 12-hour shifts on board the vessel. I'm going to talk to you today about the Herald of Free Enterprise. It was the 2nd largest marine disaster in history. The ship was operational, started its operation in December 1997. This vessel was designed, built, commissioned, and operated with a latent trigger. The door was open and closed more than 8,000 times. I'm going to show you a quick clip, a short clip of the Herald of Free Enterprise. It was a ro-ro vessel loading buses and cars on 2 decks, carrying about 500 passengers across with about 80 crew members. The vessel had a bow loading. At the front of the vessel, it had 2 doors, hydraulic doors that opened and closed. And that was, when you look at this, it had 2.5 meter clearance between the water and the main deck that the doors closed onto. So let's have a look.
The English Channel, the world's busiest shipping lane. Every day, tens of thousands cross it by ferry. It's a safe, routine trip. Until one ship capsizes just over a kilometer outside port. Within 90 seconds, hundreds of people are fighting for their lives in the icy water. 193 died in Britain's worst maritime accident since the Titanic. The day after the tragedy, investigators take a boat out of the capsized Herald. It's a shocking sight. The ship appears to be intact. On the ship's visible side, they see no immediate sign of collision or damage. But what they see at the Herald's bow astounds them. The huge bow doors that allow vehicles on and off the ferry are wide open. It's clear to the investigators that water must have poured through these gaping doors. The media dubbed the open bow doors the doors of death. How could this happen? To find out, they questioned surviving crew members who worked on the car deck that night. They learned that it's the job of First Officer Leslie Sable to supervise the loading of vehicles. It's also his responsibility to get the Herald loaded swiftly so that it can depart on time. If he fails, he could be reprimanded by his bosses.
It was such a difficult market to make a lot of money in, and of course one got commercial success by turning the vessels around very quickly.
30 minutes to disaster. The team discover that tonight Sable is under pressure. The cheap ticket deal means the car deck will be full. As the last car rolls onto the ship, the call is announced for harbour stations.
Stations, all stations. Herald of Free Enterprise, about to leave the harbour, proceeding happens.
This is the signal for crew to go to their positions for departure. First Officer Leslie Sable hurries to the bridge. They're now 5 minutes behind schedule. He is the last to leave the lower deck. Harbour stations is also the signal to close the bow doors using a hydraulic control lever on the car deck. Investigators discover the responsibility for this crucial job falls to Assistant Boatswain Mark Stanley.
Stations, all stations.
But when they question Mark Stanley about his actions that night, they're in for a shock. When he should be on the car deck closing the bow doors, Mark Stanley is still asleep in his cabin. 4 minutes to disaster. Unaware that the bow doors are wide open, Captain Lurie ups the Herald's speed half a knot to 18 knots. In the shallow water of Zeebrugge's harbour, this makes the bow wave dramatically bigger. 90 seconds to disaster. 2,000 tons of water flood the ship's open car deck. 60 seconds to disaster. As the water surges across the car deck, passengers feel a violent lurch. Now the wave starts to carry cars and trucks with it. 30 seconds to disaster. The ship tilts 30 degrees to the left. It's the point of no return. The ship turns on her side to lie half submerged in the icy waters of the North Sea.
What can we at Depth Marine Namibia learn from the Herald of Free Enterprise? The Herald of Free Enterprise is a known marine accident, and it's known to all our mariners. Flooding at sea is a known risk and needs to be carefully managed. Yet we have learned that we need to challenge ourselves, our systems, to get better to reduce the risk. Our approach to reducing risk at Depth Marine Namibia is to utilize our people, see the incident before it happened and take action to correct the systemic weakness. The process that we use is called a Delta Commander process. Delta stands for Deep Elimination of Latent Triggers of Accidents. The premise is that the latent triggers exist in any operation, doesn't matter what you do or what you operate or maintain or mine. And the approach is to look for that latent triggers. Remember, the Herald of Free Enterprise was designed, it was built, it was commissioned and operated with that latent trigger. Everybody now in hindsight would have said, but where's the indication that the doors is closed? And there was 2.5 meter difference. How many times that they operated or forgot to close the doors or half closed the doors and nothing happened? So that latent triggers needs a certain circumstances. And you'll see later I'm talking about randomness. And in the Herald of the Free Enterprise, there were certain random factors that caused the incident. The Delta system has 3 principles. System must be proactively challenged. Randomness. Randomness plays a big role in incidents. What's the random factors that contributes to the incident? And consider people as our strength. And I think that's the most important part, is that People are our biggest strength. The first principle is the system must be challenged proactively. Hack your own system, and I'll explain to you now what that means, hack your own system, by way of an example, and dig deep into the organization's system, processes, culture to find these latent triggers. And they do exist, and through this process, we've picked up a significant amount of latent triggers. And I'll also show you some examples. Risk systems must be continuously challenged. It's a continuous process to find and eliminate the triggers before the incident occurs. I'm going to use Netflix as an example of pressure testing the system and hacking the system. We all know about Netflix, watching the movies, but in that area behind the movie that we see on the screen, there's a complex network and a vulnerable network. Given the cyber crimes that we've seen lately, there's a significant vulnerability in terms of they've got offline systems, nearline and online systems. Everything has to work 150% for the viewer to experience a smooth movie. Behind it, what Netflix has employed is the Simian army or the chaos monkeys, and you could look at the word chaos monkeys as they cause chaos, and they would stand on the outside of their systems and they would try to hack. Employees or employees of the company will try to hack their own systems, find that vulnerabilities and close them. If you close all the smaller vulnerabilities, you'll be able to withstand the big vulnerability areas. So it's a method of really pressure testing and finding the vulnerabilities and closing them, so that the online final product to the customer is what wins the clients. We've got a similar process, and that is called the Delta Commander strike teams. DBM has got two processes that challenge. It's the Delta Commander process, which I'll explain just now. It's a risk system challenge. And then the Safe Sentry, which is our employees in hazard identification and dynamic risk discovery. So I'm first going to tackle the Delta Commander process. We all have in our companies operational risk management. Our critical risks has got a risk. If you've got the risks, you'll see on the right hand side the priority unwanted event or the major catastrophic risks. It's got a risk owner, it's got control owners, and we've got a whole operational management system that has got critical controls, robots, verification of the critical controls to make sure the risk is under control. Against the catastrophic risks, we then got a Delta strike. It's led by a Delta strike leader with Delta commanders. And I'll explain now what each of those Delta commanders do. So the process is that the Delta commanders assemble as a team, and most of the subject matter experts, the local employees that's been trained in Safe Sentry to realize and help then have an engagement process with the area that the Delta strike will happen on. So first, the Delta strike, as I said, will have some team members consisting of the subject matter experts and then normal crew members. The first is a blue strike, and the blue team really challenge the group or area which you strike with an unknown, unrelated critical risk. A blue sky event where you could also combine priority unwanted events. And a good example of that at sea would be you get a fire, you start fighting the fire, and we know what comes after when you use a huge amount of water. You then have a flooding risk, and the flooding risk and then becomes the vessel becomes unstable. So you've got then two big priority unwanted events that you need to deal with, and that is then put to the test as how the teams will manage that. You look at the capability of managing that. Then another risk, you have a yellow team, strike team, that assess the quality of the risk management structure and controls. Is how well is how well is the system structured, and if the critical controls are in place, and how effective the critical controls is, and there's a method of understanding how that works. Then the red team, you simulate a known fatal event and assess the capability to prevent. The green team is this team. A human is always, all of us looks for the worst and the things that's not working. And what the green team is doing is look at the best practices. In all our operations, there are best practices that needs to be shared with the rest of the company. I'm now going to cover the Safe Sentry process. Remember, I spoke about two challenging processes. The one is the Delta Commander process, and the other one is a constant dynamic risk discovery everyday process that happens on the vessel. It's conducted by the crew. So one of the crew members, 30 minutes a day, takes his tablet and walk around the vessel for 30 minutes, engage the other crew and get valuable, observe a priority unwanted event operation, or observe where the guys are working, and only look at a disabling or a lost time injury upwards. But the main focus is fatal and catastrophic risk. And then the second day, the second person walks around. It could also happen per shift, but depends on your operation and how you drive the process. The background to Safe Sentry is at Debmarie, Namibia. Fatal risks, as we know it all in our operations, are not obvious. Frontline workers know a lot. They are capable to be safety leaders if we let them to be safety leaders. Risks randomly shift in likelihood and exposure. Risks may be imminent, lurking, latent, embedded, and exist fleetingly. And we all know that operational risk management is overloaded with control, a lot of focus on control, and underloaded with discovering risk. It's not that dynamic to discover for risk discovery. We've got a Safe Sentry ad. You could see on the bottom here somebody who stands with a tablet in his hand. It's basically, the app was designed for workers. It's based on the 6 Whys, which every fatal risk that you witness is either overlooked, underestimated, rewarded, balanced, inherent, and tolerated. It has a simple risk analysis tool to understand the level of consequence. Good practices gets highlight, the discussion with the supervisor, and that's what psychological safety, in terms of your discussion with the supervisor, the persons are not, there's no fear to highlight the issue. And then random risk verification, and this is the area that we found most of our benefits. If they looked at a operation that happened in a priority unwanted event, there's 4 critical controls, and the guys have witnessed if the 4 critical controls that they could verify is in there. The rest of the app is, and we look at this on a weekly basis. You could see busy offloading the tug, and the person standing there with the app and looking at his 6 Whys in the lifting operation. The second principle is randomness. Our approach to randomness is a risk system must be resilient to withstand random factors. which significantly increased the risk. And we'll now go back to the Herald of Free Enterprise. And we look at, for a system to be resilient, it must be able to withstand random factors. The Herald of the Free Enterprise had significant increase in their risk. When that doors was opened, the random factors was the cheap tickets, pressure to produce, rushing, rolls, sleeping in, and door visibility. Remember, when they were rushing, they were only 5 minutes late, but a heavy competitive industry. Lack of role clarity, the sleeping in, the relying on a harbour call, harvest all over, missing a harbour station's call, and the door visibility. I think all of us will look at this now and says, but where's the captain should have visualization of the doors are closed as a backup in the bridge. But at that stage, all the ro-ro vessels and vessels operating on that protocol didn't have door visibility. We need to fight randomness with randomness. The Delta Strike teams can go anywhere on the ship, including the high security zones. The Safe Sentry can do his Safe Sentry walkabout any time of the day, any time of the night. And on the right-hand side, that's what our Safe Sentry picked up, a fatal risk. Somebody that stands on a beam, and if it was me, I would have probably not been able to stand on the beam. I had to climb on the rails to clean a camera, a security camera. And if that is a half a meter over the side, if the ship suddenly roll, that person will disappear into the ocean. Being at night, hypothermia, he's basically got 30 minutes to an hour in the water. If nobody picks him up, then he would pass away. All shifts are challenged, as you could see on the night shift, and the challenge is influenced by tide, current, salt water, weather conditions. It's really trying to put in the random factors, and you've seen on the Free Enterprise the random factors that played a role in their catastrophic. For years, nothing happened, and then all those conditions and that factors made it happen on that fateful day. Documentation forms the basis of the discussion, but it's just a discussion point that you start your overall strike process with. The bow tie is reviewed, the critical controls is reviewed, the effectiveness of them, how often are they verified. The risk log is looked at, and then the dashboards of how effective the critical controls also look at what critical controls has failed and if corrective action was taken. And then the JRAs and the planned job observations are also looked at. The benefits of the Delta process, and I'll go through some of that just now in detail. What we've picked up during our Delta strikes, and you'll see how valuable this is. On the left-hand side is this door was pinned open. Now, the reason why the door was pinned open is because this particular door caused a lot of finger injuries. And to prevent the finger injuries, we then decided, the team on board the ship then decided to open the door with a hatch. Now, the problem is not this door. When you walk through the flooding of the possible flooding and combination of the areas or the priority unwanted events, the door before this is a weather-tight door. And if that door is maybe left open like in the Herald of Free Enterprise, in the area of floods, this area leads to a bigger flooding area. So if it's pinned open, the water overfloods in here, it floods to what you see on the right-hand side. A big area of about 30 by 40 meters. And we know that free surface areas, when you have a significant amount of water, you could easily get 500, 800 tons of water into a big area that causes a free surface effect. And as the ship rolls, this is going to cause some trouble. So this is the same risk that we picked up on one of our vessels as what the Herald of Free Enterprise had. In this area, what we've picked up is this is a subsea tool with about 8 meters going down. And in this area, there's no anchor points to work at heights. And there's poor lighting working at heights. You could see that area of platform when the person stands. If there was no hooking points and you've got an 8 meter fall down there. Also, the going down the stairs or the ladder would also be problematic. If you don't know the vessel by heart, there's a critical submersible pump that's at the back of that. And if you have suddenly a change of chief, second, and some of the engineers, and you could easily forget to maintain this critical submersible pump, which could, a small thing like a pump could sink a ship. This is another area which we had big benefits from, is we call the red strike in a shell area, which is the recovery of the vessel where we recovered the diamonds. And we simulated that there's going to be a fire inside the recovery. Now, if you look at the left-hand side, and the left-hand side of the two pictures with a VA set and a person that and there's not a lot of people that goes into the high-risk areas. And it's small, confined areas. So if you've got a PAC full of smoke, you're not familiar with the areas, you're really disadvantaged. What we've also picked up is that because of the high-risk areas, we do fire risk drills. We do drills all over except in the recovery area. So the fire capacity and capability inside the recovery is also problematic. And you have to open the door to bring some additional firefighting capacity and medium from the outside. On the right-hand side, you can look at, when we looked at the rescue plan, some of the doors that's not often used to take out things, or in that time, there was a cable tie normally tied to some of the doors just to keep it closed, because you could still open it from the inside and push it out. And what happened here is one of our security members will keep on replacing a cable tie, and then in that time decided to put a cargo seal in there, a piece of steel basically. And if you in an emergency want to escape, you've really got some challenges if that's your only escape. In terms of what we picked up, one of the good practices is our emergency preparedness and drills. But as you could see in the previous one, it also causes, if you've done 79, 80 emergency exercise, you're quite comfortable dealing with emergencies. But you can get that false sense of security that I can do an emergency anywhere. And you select the recovery area and you're at a disadvantage. But our emergency preparedness and response, as you could see there, we're really trying, it's not paper-based exercise or desktop exercises. It's a physical, when you got your immersion suit together with a life jacket, it's physically done. The BA set is the person goes under the air. And then helicopter operations, that's quite straightforward. Night landings on the, we don't do night flying, but in case of an emergency, the pilots have to stay current to land on the deck at night. And then I don't know if you've experienced before putting a stretcher or carrying a stretcher inside or outside a ship on stairs going up and down, even in a building, that is significantly challenging. And if you don't practice that, you're never going to take an injured person out of a building or a ship. Reducing the risk, our approach, we treat people as the strongest link in our risk management chain. But it's not always the case.
The investigator's final report finds that the Herald's loss is largely down to human error. Captain David Lurie is suspended for a year. First Officer Leslie Sable for 2 years. And the man who failed to close the bow doors, Assistant Boatswain Mark Stanley, is found seriously negligent but escapes further punishment.
Therefore, people are always seen as the weakest link in our risk management chain. What should have actually happened here is the management and the leadership should have found out why they failed. People are our greatest strength in terms of our cultural strengths. Your challenges are welcome. You always challenge and pressure test the system. And if you find a weakness, it's welcomed because the incident hasn't happened and you've got an opportunity to fix it. Finding and correcting control failures before the incident is a good thing. We don't like bad news and we don't like when things fail, but if they failed before an incident, it's a good thing. Pursuing every control failure until it is systematically fixed. You don't fix a control failure by a procedure. You look for other areas and methods and reasons why the control fails and change the control. Imagining and mitigating low probability and high risk consequence events. We look at our risk log and we look at our risk matrix, and there's some significant events that we don't deal with just because of the likelihood. It's a blue swan, it will never happen. It hasn't happened in 100 years, so why would it happen now? Another important point is we celebrate the red challenging the green. In our robots of critical controls, when we do pick up a red, a failure, we celebrate that because that prevented a fatality or catastrophic event. And if you just see a green robots, we all get comfortable, but that's the time to get uncomfortable. The benefits of the Delta process, it's opportunity for the workforce to focus on management, system, and processes. They help you to pressure test your systems. It's unfiltered risk visibility. There's nothing that could be hidden here. It is what it is, and you have to then fix it. It creates that chronic unease that systems and processes could fail. On the free enterprise, the management possibly at that area, that time, thought that all the risks are mitigating. But when you add the random factors to it, special conditions, at that time, the risk materialized. So you need to have that chronic unease in a risk management system. And I think the most important part is we are seeing and correcting risks before an incident occurs, which is the bonus. Our focus, we find and are focused on incidents before it happened, which allows us to manage risks minute by minute because they are always changing. Risks are dynamic. They always change. And as we discussed, the randomness really and the random factors have a significant influence over the risks that we manage. Thank you for having me at the Safety Connect 2021 Safety Conference.